there's something wrong with MCPs. In fact, Anthropic has fully admitted that MCP is great, but it has really huge problems. The problem is it sucks up all of your tokens. As we know, tokens are very expensive, and so we need to be really careful with that. The good news is they've released a solution that will allow us to cut down the cost of tokens about 98%, from 150,000 tokens you might be using MCP servers down to about, let's say, 2,000 tokens. That's huge. In this video, I'm going to show you exactly what the solution is and how they came about doing that, and then show you the strategies for you to implement using this new solution to cut down on cost, because nobody likes cost. Okay, let's go ahead and get started. Okay, so if you ever build an MCP server, you will realize that MCP servers burn tokens. The reason being is because if you look at MCP servers, you will notice that you have to create the tool definition. So this is where you put all of the functions, signatures, parameters, descriptions, and all the other things you need. So this is the sort of a core, the map that your code, the MCP server, will need to be able to find the functions, the things that it needs to call. But all of that, it's a lot of stuff. So all of this is actually passed along as context for the large language model. And what does that mean? Well, it means that every tool is loaded into context window for every request. So you can have 5, 10, or even 100 tools in your MCP server that you have created and defined. And each one of these tools could have 2,000 to 5,000 tokens. Now, just to do math, if all of that is being loaded into the context of our large language model, then we end up with a lot of tokens that are wasted, 10,000, 50,000. And that is the problem, because number one is inefficient, but also we have higher cost. We don't want that, because if you multiply by every agent call your workflow does, then lots of money is going out the window. And so that is the problem that they also have admitted, they being the Anthropic team. Now, the second problem that we have here is very inefficient as well, is the fact that we're also passing a lot of the information that is unnecessary, this intermediate information that is loaded between the agent and the tool call. Right? What happens is that the tool returns a lot of tokens, a lot of information, because that is what we need for the agent to work. And then the agent keeps calling to the next process. And then the large language model is going to process all that information, including the 10,000 tokens of information, to the next call. So now we have another tool call, which will have that 10,000 tokens included, and then the cycle repeats itself. So now 10,000 plus 10,000, you can see that there's a lot of tokens that are being passed around that it's really not necessary. And problem number 3, you can see that the problem doesn't end here, is that now if we have a workflow, agentic workflow, this can end up being very expensive. The reason being is because imagine that we have the first step. So we initialize everything, which means we load tool definitions, which could be about 30,000 tokens that we're burning. And then the second step, we have the tool call, the actual tool call, which is going to process large results that we're getting from the tools we're passing to the large language models. And then we have another call, because we may have another call to a different tool that will add, let's say, 20,000 tokens. And then we have the final result, which is now the synthesis of all the tools, all of the context, the results and everything from the large language model that we're back and forth with agent and the tool calling. So now we have extra 10,000 tokens. This is real expensive because we may end up burning through just one cycle in our workflow here about 75,000 tokens per run. Now imagine that you have a workflow where you're doing maybe 15, 17, or even 100 runs. So this is a huge problem. This is why Anthropic had to find a solution for this. So as you can see, it's imperative that we have a solution. And of course, we do have a solution by Anthropic. So here you can see the impact before versus after optimization. So stay tuned. Of course, I will show you exactly the whole map that I talked about. Okay. So traditional MCP, this is the current problem. We said we have a lot of token usage per workflow, and then the cost per 1,000 run could be upwards to 225. Okay, this is production level. Context window usage is very, very high. But if we have everything optimized, the potential approach I'm going to show you here is that the token usage per workflow could reduce to 10,000. This is from 75,000, and the cost per 1,000 runs, it's only $30. So these are just estimates. And of course, the context window usage is going to be low. So that is the promise with this new technique. Okay, now let's go on to the solution to this problem that we have with MCP. Okay, so what is the solution? The solution is what we call code execution with MCP or with skill. So they put out this article here, Code Execution with MCP, Building More Efficient Agents, to illustrate this problem that we talked about of massive usage of tokens using MCP. And so they go over everything here, explaining what Model Context Protocol is. By the way, if you want to learn more about MCP, I do have a video somewhere we can find and learn more about MCP servers. So they talk about all of that, and they talk about the excessive token consumption from tools makes agents less efficient, as we have discussed earlier. So they go through the process of saying how tools definitions, they tend to overload the context window, as we see, and all of that. But the solution is really awesome. So here to talk about the actual solution. So the idea is that to have the agent write code which will then invoke the API. So instead of having all of the functions, all of the context that is loaded onto the agent from MCP way of operating, now we're going to have some sort of a sandbox where the agent is going to be able to write the code when it needs to call a certain tool, as opposed to have all of these pieces dumped onto the agent. So that's essentially what they're talking about here. So the idea would be to have the server where we have divided Google Drive as a tool, and then inside of that we have the get document TS. So that would be the file that will be called when the agent needs to call that API. Okay, so we have other tools in there. We can have yet another tool, Salesforce, as a folder, and then we have this, for instance, update record.ts. So that would be the code would be written and run by the agent to go and fetch just that tool that it needs. So essentially, the agent is going to go ahead and discover these tools by exploring the file system that I showed you at the top here. So we go to that servers and go to directory to find the available servers. So like I said, you could go and find the Google Drive, find any other tool it needs to use. And this is amazing because it makes agents more efficient at using these tools, because not only are the agents minimizing the amount of tokens that they need, they just get what they need. So you can see here they say this reduced the token usage from 150,000 tokens to 2,000 tokens at a time, and cost saving 98.7%. That is insane. This concept of minimizing the imprint of usage of a lot of tokens, it's not a new concept. Anthropic used this same concept when they built Skill. So Skills essentially is a package that you can create that allows you to add all of the repetitive tasks that you may have, essentially all the instructions to do a certain task. So you put all in one package and then run with it. So that Claude, in this case, is going to be able to infer that skill whenever you type something related to that skill. Okay, so you can say, please write me a blog title, blah, blah, blah. And so if you have a skill that was already installed, Claude is going to go ahead and pull that. Now, the beauty of Skills is that the same concept, as I said, is being used here, which is allowing agents to only take what it needs, in this case, the description of that skill, instead of loading everything. So the same concept, it's being borrowed using the code execution, because now the agent at start time is going just to get the description of those instructions, the description of those tools, instead of having everything loaded onto them. That is the strategy used internally to minimize the overloading of tokens to the agents. Now, this concept is very important because the idea here is that instead of loading all of the capabilities that are available onto Claude, in this case the agent, we just allow it to get the pieces that it needs before we load everything. So think of Skills as knowing where the toolbox is instead of giving you all the toolbox. So if you know where toolbox is, it's easier and it's not as heavy to having to carry all the toolbox with you. And this particular concept allows for code execution and Skills to really optimize the consumption of tokens, because only what's necessary, it is indeed what is passed around the agent. Now let's go ahead and see how code execution works along with skills, because these two technologies have a lot of similarities, at least on how it optimizes the tokens and all of that. Now, before I go to that, I would like to let you know, if you're liking this video, go ahead and hit that thumbs up. That way I am inspired to continue making these videos, because making these videos is actually a lot of work. More work than you can ever imagine. But go ahead and do that. That way will make me happy and also make the algorithm happy, and show this video to as many people as possible who would find this also very useful. Okay, so here's a clean architecture of how MCP works, but also how the code execution will work. Kind of like a contrast between the two and how everything comes together. So you can see here, the first thing is we will have the LLM client. That is the first component. So first we have the LLM client, which connects to, in this case, could be the component 2, which is the old way using MCP server, or use the new way, skills and or code execution. So the idea is that both of them will end up with results, but the old way, we have JSON tool schemas, as we said, and that adds a lot of tokens that are being burned. But the new way, it's way better, and we get a result which goes back to the large language model client. Now the LLM here, this is your client application, right? So it could be Claude, GPT-4, what have you. And so the client is going to connect, of course, to the capabilities as we spoke earlier, right? The tools, skills, and everything. And this client is going to be able to invoke those capabilities. And so when those are invoked, then something happens, an action happens, which means, for instance, how to write an essay and all of that. Now, traditional MCP, which is the old way, the MCP is going to have to define the JSON schema as we saw. So define the parameters, types, description, and every tool will get loaded into the large language model context upfront. So everything is loaded upfront. So when the large language model wants to use that tool, what happens is going to call it by name with all the parameters that are needed, and then those results are sent back through the context window. So you can see we're adding stuff to the context window, which gets larger and larger and larger. Now, so here's how a traditional MCP works essentially. So the first one, we're going to load all the definitions. So if we have, let's say, 10 of these or 47 of these of the tools, which are just functions, we're going to have tool schema 1, for instance, get weather. This could be 500 tokens. I know it's a little bit small. And tool schema 2, search database, 800 tokens. So as many tools as we may have as definition, they add up in tokens, as you see. So you multiply that by 47 tools and more, you get the idea. A lot of tokens. And then all of that is front loaded into the LLM context window. So all 50 plus tools definitions are loaded. So now we have 25 to 50,000 or even 100,000 of tokens used before any work. So nothing has been done. We're just loading stuff. You can see how inefficient this is. And then we have step 2, which is going to be the large language model is going to make a call. So it's going to call, let's say, get weather tool, pass it the parameter and everything. And then the tool is going to get the result. So the result is going to have, let's say, 10,000 tokens back to the large language model. And the step 3 is going to go and repeat for each tool call. So now every time the model or agent needs to do that call, it's going to go ahead and do the same thing. So you can see we have tool definitions, we have to pass in parameters, large results are coming back. So we're adding more and more and more, which becomes unbearable in terms of tokens. So you can see that the context window is going to get full really fast. 90% full, not good. On the other hand, if we have a skill or code execution, it's a new way. It's different because instead of tool definitions, what we're exposing is the capabilities as executable TypeScript code. What does that mean? That means the large language model is not going to be calling any tool. All it does, it writes the actual code that imports the API and uses it like any developer would do. So the idea is very simple now. Look how clean this looks. So now step 1 is we're going to expose the minimal API. So we have this lightweight API definition, something like this as you see here. And that is indeed what is then loaded into the LLM, which is going to write a TypeScript using this lightweight API. You can say, okay, I will need to get the weather, which means I'm going to load the weather. Okay, I'm going to get the database, email, and all that. So I'm going to just load what I need. And so the large language model writes the code because it knows from the API definition what it needs to write. And that code is then put in a sandbox where it's going to go and run and do the actual call to the API to get information. And that result is returned efficiently. Notice the difference now. Because we're not front loading anything, the difference is that now the LLM context is 2,000 token total. So 95% free for actual work. Here, we had 90% full. So at the end, we had a lot of tokens. But in this case here, because we're not front loading everything, right? This is what happens. Now we are saving a lot of tokens. Okay, so let's look at this real example getting weather data, right? So we can see how this would work in a real example. So using a traditional MCP way, so again, we have tool schema, load all the context in, as you can see here. Whereas code execution way, we have the AI import minimal context. So we just say something like this: import weather from capabilities. For example, this is only 20 tokens. This is about 500 plus tokens. That's the difference. And then we have the LLM writing the actual code, right? Very simple. And then returns the actual result. So you can see for traditional MCP way, we have the LLM tool call, which adds another 10,000 tokens for the same thing, by the way. And at the end, you can see that total tokens for the MCP way is about 10,500 tokens, and total tokens cost. And total token cost for the new way, which is code execution, is about 200,000 tokens. Incredible. So you can see the differences here. So I hope this is actually making sense. I wanted to go deep so you understand exactly how these technologies work, right? So you really have that concept. I hope this is helping. Now, before you go in and drop everything in favor of using code execution, remember that when you allow large language models to create code, there's some risk involved as well, because even though this code is running in a sandbox, things can happen. So security is a huge thing, and I'm sure Anthropic will be fixing or figuring out a way to make sure that this is more secure. Okay, just something to keep in mind. Also, you could introduce some malicious code that ends up in infinite loops and sort of kind of infect your entire sandbox. So that is another issue that you may end up having when you have large language models creating these codes. Also, we could end up with data leakage from the sandbox, which causes many other issues, many other side effects as well. And remember, writing code means you are importing a lot of different libraries, and some of these libraries that may be imported by the large language model when writing the code, they may be infected, they may have some issues, and they may be compromised. So that is something to also keep in mind. I put together a very simple demo that is demo only, so you can see how all these pieces work together. So using MCPs and how MCPs take up a lot of tokens and that gets expensive, and the new way by using code execution with skills, which is the better way to optimize the token usage and cost. All right, so I have here some code. Again, this is purely for demo purposes. The idea is that you can see that this is actually a node project, but the idea is that we have a few things here. The first one is that we have the traditional MCP server, yes, to again show you some code here. So essentially is what I have shown you before. So here we are setting up everything where we're going to be calling all of these tools. So we have interfaces and everything, and then we actually have the tools, which we here define all of the tools, right? What description and the input schema, the units, and all of that. So exactly what I've shown you how MCP servers work when you want to create MCP servers. So this is just to demonstrate what it takes. Okay. All right, so and then I have the same sort of structure, but for skills version. I call it skills because the same structure, the same mechanism as code execution works the same. So the difference here is that for skills, as you can see, we only have very simple thing. So you can see we have the description of what it does. So description interact with the weather data API to get current conditions. So this is what is going to be front loaded to the large language model, which of course using the code execution will actually implement the code to call the tool and do the API call. Okay, so the difference here, you can see it's very different because now we have the description.txt and we have the weather skill, which would be the code that would run. Okay, so click here, you can see this is the actual code that goes ahead and actually does what it needs to do, which is to fetch the weather information. So let me go ahead and run this. Again, this is just a demo to put together all the concept that we've learned so far. And let's go ahead and run this so you can see the differences. So I have set everything up. So I'm going to run compare tokens, which is a TypeScript file that goes ahead and run both of those files and give you an overview of what happens. Okay, so it's going to go ahead and run this. Okay, so now it's running and all of that. So now I have this console here that shows exactly what happened. So you can see we have here token usage comparison, traditional MCP versus code execution skills. So it's going to go ahead and analyze the token usage. So measuring traditional MCP server, you can see the description tokens is only 33 for the skills because it didn't have to pull everything. And the measuring skills code loaded when used, single function call, because we just want to call one function, 68 tokens, multiple function usage, 154 tokens. So if we wanted to call multiple function, which happened, it would end up being 154 tokens. Now, the result summary, traditional MCP server, the tokens loaded upfront was 1,391. The cost per conversation starts at this amount here, okay? And all tools loaded before user sends first message. Exactly what we saw before, everything's gonna be loaded. All the tools, all of the schemas and everything. The code execution, on the other hand, simple query. What happens is that tokens loaded up front, 33, tokens loaded on demand, 68, total tokens, 101. So cost per conversation, this amount, way less than what we have here. All right, so token savings, 92.7%, and gives us other information as well here. Now, the important thing here, when we look at a micro level, things may seem, that's bearable. But when you're looking at just production level, macro level, you can see at scale, let's say we have 1,000 conversations a day. Let's do some calculations here. The code did it for us. So for MCP daily cost, it's going to be $4.17. So skills daily cost is going to be 30 cents for the same 1,000 conversation per day. Okay. So daily savings is $387, daily savings for complex $361. So you can see that yearly savings for the simple is this amount here, and for the complex is about this amount. That's huge, huge savings. Okay. Now let's go ahead and do 10 services. This is part of extrapolations. So for the MCP server will be this amount as we saw if we're running 10 services. Skills is going to be this amount for the 10 services. And we have the daily cost for 1,000 conversation again. For MCP is going to be this amount. For skills is going to be that amount. That's huge reduction. And savings per day is going to be that amount. And this is going to be $14,000 a year of savings. Okay, these are just demonstration, but you can see how much we're saving using this new strategy. Okay, let's talk about the key takeaways here. The first one is that skills loads 98% plus less tokens up front. That's amazing. Even with on-demand loading, skills use 70 to 85% fewer tokens. That's huge. And at scale, let's say 10 services, yearly saving around $25,000. Skills provide flexibility. Agents can combine functions, as we saw. MCP is still valuable for control and predictability. We're going to finish finalizing, okay? And we're going to talk a little bit more about this part here. All right, so after all of this, what is the verdict? Should you just ditch MCP? Well, I don't think so. I think MCP still has a place, and that is the challenge, is for you to figure out when to use MCP over using skills and or code execution. So here's what I think you should think about. Use traditional MCP servers when you need to do the following. If control is the most important thing for whatever you're building, then you should use MCP. Why? Because with MCP, you're able to define exact tools and parameters that you want for your agents to be able to grasp. If you want a more predictable workflow, then you should use MCP, traditional MCP, because in those cases, it's important what you see is what you get. Also, if security is very important to you, go ahead and use MCP servers, because With MCP servers, as you know, everything is defined. There's no need for arbitrary code execution and creation by the large language model. If you want a more simpler way of dealing with communicating, giving access, or in this case, adding context to your agents, so you have easy credential management, no sandbox complexity, and all of that, then MCP is the way to go. Also, if you want to be compliant with certain laws and rules, you want to have a more regulated environment where your tools are being served from, then you should use traditional MCP servers. Now, here's when you should use code execution with skills. You do that if you want maximum flexibility. Agents can create custom workflows. If you want maximum efficiency, 84 to 99% of efficiency, in this case, token reduction upfront, that is huge. If that is important to you, of course, you should use code execution. If you want more scalability, allow your agents to be able to tap into dozens of different tools and capabilities. And of course, code execution is going to be great because it's not going to front load everything onto the agents. If you want autonomy where the agent is literally doing everything, including writing code, then of course you do that. Also, if you are in the front end of innovations with agents being able to sort of create new paradigms of discovering novel APIs out there, then using code execution is going to be the best way to go. All right, so this is the end of this video, folks. I hope this was helpful. I hope you're seeing the differences. You're seeing what's happening in the AI world when it comes to optimizing MCPs in essence, and different mechanisms to save on cost when it comes to context windows and tokens when we building our AI-based applications. So let me know what you think of this video. If you have any questions, and tell me, I want to hear from you. Don't forget, always leave comments in the description, the videos you want me to cover, or rather the topics you want me to cover, as well as what you think of these new tools like code execution and skills. How does that fit with what you want to build, where AI is going? Because it's certain that Anthropic is moving forward. In fact, these tools, these new technologies, other companies such as Google and OpenAI are also starting to use them. So maybe it's going to be a standard just like MCPs are right now. Okay, that was a lot. Thank you so much for your time. Really, I appreciate that you made to the end of this video. And till next time, be well.